This next example problem is similar to the last in some ways, and that I gave you a more complicated circuit, and you need to find R net and I net, and you're going to need to find the current everywhere. Then based on that, we're going to do some additional questions. If you want to pause it here and solve for R net and I net, and probably the power as well, do so and then come back and we can go through the next part together. I'm going to go ahead and start solving it. These two resistors, the 6 and the 4, are in series, which means I can just straight add them and they combine to make a 10. So coming from the battery here, we go through a 2, continue on, then split into a 10 branch and a 40 branch. These two come back together and then go through the 10 before heading back to the battery. Notice it doesn't make a difference if I draw it this way or if I draw it that way. I can always bend the wires as I see fit, as long as I'm not changing where a junction is or moving resistors over a junction or anything. Excuse me. Next, I'm going to combine the 10 and the 40. The 10 and the 40 are in parallel, so we add them by adding their reciprocals. E equals 1 over R. Solving for R, we get 1 over 10 plus 1 over 40, 1 over my answer, I get 8. Redrawing this again, 2, 8, 12, back to the resistor of 80 volts. Now I'm ready to do R net. I have one loop, everything's in series, so I can just straight up add 2 and 8 and 12, add to 20, and R net is 20 ohms. I'm going to get my current next. So I have my net voltage, I have my net resistance, so I will do V equals IR. 80 equals I times 20. I is 4 amps. For this circuit and everything after this, if I give you a complicated circuit, I'm going to make sure that I net is a whole number. If you get a decimal or a fraction for I net, something's off. I do not guarantee that the current through each branch and through the whole circuit, or throughout the circuit, is a whole number, but I net will be. So that's a good indication I did this right. Okay, power for the whole circuit. Remember, power equals I squared times R. I use I net, I use R net. 16 times 20 is 320 watts. D. I'm going to find the voltage across the 6. Before I do that, I need to split my current through this whole circuit. I have 4 amps leaving the battery. And it's going to stay 4 amps until we get to here. Some's going to go this way and some's going to go that way. It's easier for me to see it over here where I've combined it. Where I've combined the 6 and the 4 to make the 10. This branch I will call X. That branch I will call 4X. 4 equals X plus 4X. X will equal 4/5, which is 0.8. So 0.8 amps go this way and 3.2 amps go that way. Or 3.2 amps here, 0.8 amps here. They will join back up, back to 2 amps, back to 4 amps, and then 4 amps returning to the battery. Now that I have the current everywhere in the circuit, this problem's a piece of cake. If I want the voltage across the 6 ohm resistor, V equals IR. I use the current through the 6 ohm resistor, which is 3.2, and the resistance of the 6 ohm resistor, which is 6. 3.2 times 6, 19.2 volts. Power in the 40 ohm resistor. P equals I squared R. I in the 40 ohm resistor is 0.8. The resistance of the 40 ohm resistor is 40. So I squared R will be 0.8 squared times 40, 25.6 in units of power are watts. I in the 2 ohm resistor I've already figured out is 4 amps. The voltage across the 10 ohm resistor, V equals IR. I through the 10 is 4. Voltage across the 10, I'm sorry, the resistance of the 10 is 10, giving me 40 volts. Okay, you're ready to attack your homework.